Hello, my name is Lieutenant Colonel Roland. I'm with the Civil Air Patrol, and well, this is uh, this is our third presentation for the museum, and this is a great honor for us to be here to work with the museum. And I'm the director of aerospace education for New Mexico Wing, and today we're going to talk about we're going to build a might be able to see it here. We're going to build a paper airplane. But in relation to this paper airplane, we're going to find out, could we fly this on Mars? And so a little bit about Civil Air Patrol. We're we're volunteers. We're auxiliary of the Air Force. We're a partner of the Air Force. And we have three missions: aerospace education, which is part of our mission today. And we also have cadet programs where cadets become 12 through 18 can learn about leadership, learn about aerospace education, and then we actually give cadets O-rides in the balloon that you see there that we have in New Mexico, a glider and power airplanes. We also give O-rides to teachers. We have a teacher program called AEM. Teacher can join for $35 for the first year, but then it's free for each year after that. But I'd like to talk today about, about can we fly this airplane we're going to make on Mars? And so to work into that, we have to find out a little more about Mars and its atmosphere in relation to Earth's atmosphere. We're sitting at the bottom of the Earth's atmosphere. You can barely see a little line around here. It's very small. It goes around the Earth. Can't see it on this one because actually it's the atmosphere on Mars is extremely thin. And so, but anyway, let's, and you can see there, it's about the half size of Earth. Its atmosphere volume is less than 1% of Earth. You'd have to go up to at least 28 miles above the Earth to have the same pressure that you would experience on Mars surface. I put this in here a little bit to show you some of this red line that you see here is actually the pressure. Now this pressure is being shown in millibars, and I'm more familiar with PSI, pressure per square inch. So we're using the aviation field a lot. And but you can see here that as you go higher, this is the altitude that you would be going up. As you go higher, the pressure on air pressure of the atmosphere keeps getting less and less and less. This is the air pressure in millibars down here. And anyway, so there you can see that we've had balloons that go up fairly high, up to about 30 kilometers. But in airplanes, and they fly, this 747 is probably about 33,000 feet, somewhere in that area. So you can see that you can translate these to feet if you need to. Now the pressure at sea level, 29.92 inches of mercury. That's about 14 pounds, 0.7 pounds, and that's the millibar pressure. But as you go up higher, and now Mars is going to be somewhere around here. So you're going to see there's very little pressure up there. And that's why you have to have a spacesuit to get up there. Matter of fact, this is a picture of Captain Joe Kittinger back in 1960, jumping from a gondola that took him up to 100,280 feet. Now, that was 52 years ago. Now, since that record was held for 52 years, now since the two other people have broke that record, but back in 1960, they didn't even know if you could survive at that altitude. That's way up in the stratosphere. Nobody had gone up there. Notice he is wearing a spacesuit in his jump, and as these other two did also. But now the pressure. Now Thursday, the Captain Leclerc, Captain Leclerc, he gave a talk about this Mars helicopter. Yeah. And notice the pressure on Mars is about 6 to 7 millibars. And remember, at sea pressure here, it's about 1,000 some millibars. And the PSI, very, very small. Now, remember, this helicopter was about 4 pounds then. If you multiply, well, let's see, it's only about 1 pound for the gravity on Mars. But if those rotors have to spin about 2,400 RPM with a tip speed of about 343 miles per hour to get any lift at all. Of course, we're going to see what happens in the next few days. And I thought this would be interesting. And then yesterday, Lieutenant well, the lieutenant gave this names are, I know all their names are well, but I'm nervous. But anyway, he talked about the parachute that had to take Perseverance down to the surface of Mars, and they actually got a picture of that parachute. Now that parachute had to open and work at 1,000 miles an hour. I thought I'd throw this picture in here. This is the tallest, biggest volcano in the solar system. It's on Mars, but I put it on here because you could see a little bit of an atmosphere here. And but you know, this volcano is, like it says, 374 miles in diameter. It's got a height of 16 miles. Now, if you set this volcano over Arizona, and it would completely cover Arizona. If you drove over to Gallup to look at it, you wouldn't be able to see much of it because it's so high. It goes up 16 miles. Consider the Sandia Mountains that are about a mile high in reference to our altitude here at Albuquerque. Stack 16 more of them or 15 more of them on top of Sandia there, and that's how high this thing is. It's pretty big. Well, I wanted to talk something that happens on all planets that have an atmosphere. This happens on Mars, this happens on Venus, happens on Jupiter, Saturn, Uranus. They all have a vortex at their poles. Earth has one at its North Pole, it has one at its South Pole. Now the South Pole, the North Pole, and kind of drifts sometimes. They generally stay around the pole itself, about a 600-mile diameter, but then they tend to drift because of air currents and things. And that's one of the reasons that Albuquerque and Texas and all of the United States became so cold recently, is that vortex on the North Pole shifted down towards the United States and made it, southern, and made it very cold. You can see here, because this vortex, it's kind of like a tornado, or kind of like something, the weather we have here, but it's gigantic, and all the air, it's a low pressure, so all of the air here is coming down into it, but because the space radiation is outbound, it's very cold. So now that's why we have ice on the North Pole and the South Pole. Now, the one on the South Pole pretty well stays stationary, although it shifts a little bit, and it can change temperatures of Australia and those southern countries. But the reason I'm mentioning this is because I'm going to show you something that, now because of this too, notice these winds around here are very, strong winds. Let me go to the next. Here's actually a picture of the polar vortex at Mars. You can see the cloud here. It's just a little off the thing, but that's one of the reasons that Mars does have a polar cap, is because that cold air is brought down and makes it even colder and freezes any water vapor and carbon dioxide that's on the planet. Here's a picture of Saturn's polar vortex. Now, because of this vortex in the southern hemisphere, it creates a lot of high wind that goes over mountains. And when high wind goes over mountains, it causes these waves. And you'll see these same kind of waves going over Sandia in the mountains around here that cause clouds to look like lens, like a glasses lens. And they're called lenticular clouds because they look like a lens. And if you can get a glider in one of these currents going up, then the glider will go up with that. And that's why I wanted to show you this. This is a project going on now. They've been on for several years trying to make an altitude record with a glider. Notice the length of those wings. They're very long. They're 84 feet as it shows there. It's a pressurized cabin. They pressurize, there's no motor for this glider. They have to use batteries. They have to pressurize it. It gets very cold at the altitude they're going to. And so they've had to test everything at those cold temperatures to make sure that the controls don't freeze. They have to stay warm. They wear warm suits that keep them warm. Now, something a little bit, and here it is. Here's the glider at 76,124 feet. You can see the curvature of the Earth, and you can see our atmosphere, very thin. Anyway, so, but here's a little video that I'm going to play for you that tells you a little more about this program that they're doing.
We're not seeing that video yet, just a still image.
Say again?
We're not seeing that video yet, just a still image.
Oh, no. Okay, let me, why aren't we seeing that video? Let me try another way. I thought I had it embedded in here, but let me see here. I thought I set up my save, my share. Oh, maybe that's the reason. Let's try again. Okay, let me know if this is, if you can see this. Are you seeing it now?
So the screen went blank on our ends, like a kind of gray. So it's not showing the PowerPoint. Oh, I hear it.
Okay. Okay, you hear it, but you can't see it. Okay, let me try another way to get to it.
Yeah.
Okay, we got. Okay, that, and I'm going to go down here to. Do you see the screen starting to now?
And it's just all gray on this end still.
Well, darn, I wish I could show this. So you don't see it now?
No, we do not.
Oh, darn. Well, darn. Well,
Sorry.
I'll tell you about it.
Done with the
I will get back to the other. You can go to their website, parionproject.org, and you can find that video. I'm sorry that it didn't work for. Now, do you see the slide presentation now?
We see files at the moment.
What do you see now?
The same screen it still looks like, at least on my end.
Okay, so I'm going to, I messed it up somehow. So before I started that video, you were seeing the slides go by, right?
Yes.
Okay. Me.
The wonders of Zoom here.
Was paused. Let me start share again. Try this. Unfortunately, being new at this stuff, things go wrong.
No biggie at all. We're hearing something, or we were for a second there, but then just seeing the files.
Just seeing the files. Well, hold it. Okay, you're just seeing the stop share. Let me try share screen again.
Now we see the slide presentation.
Now you're back. Am I back to the slides?
Yes.
Okay. Well, we'll skip that video, but as I said, you can go to Parolin. Parolin2 or parolinproject.org, and you can see all about this program that they have. Here's what the glider looks like. And so they were in their video, they talk about they're going higher than the SR-71. That's why I stuck this one here. So you can see that just by glider, they're going up very high with that glider. Wow. Well, talk about gliders. In Civil Air Patrol, we have gliders that we teach our cadets how to fly. I've had a young lady that soloed this glider when she was 14 years old. She got her private pilot in Civil Air Patrol as in the glider. She went to the Air Force Academy and she was in charge of, while she was a student there, in charge of their cross-country training program and flying gliders cross-country. She's graduated. She's a second lieutenant in the Air Force. But this is one of our gliders. It actually was an Air Force Academy glider. You can see the paint job here that it has. And then they got new gliders. They turned these gliders over to Civil Air Patrol because we're an auxiliary of the, we're civilian auxiliary of the Air Force. This is the glider we have now here in New Mexico. We keep this in Socorro and we give our cadets orientation rides, our teachers orientation rides and things like this in this glider. Well, here's another glider, and this is the glider that we're going to make today. And I hope you was able to go to the product page and to our presentation, and you download the paper that gives you that. It's I'll unshare a minute here so you can see. This was, now you can use, if you don't have this, you can use a normal sheet of paper, 8.5 by 11, and do the same thing. And actually, when you follow all the directions that you have on that, this back up here, this is what the glider will look like. And so I'm just going to go through now, and we'll make a glider. Let me see if I can turn this so you can see what I'm doing down here. Yeah. So we're going to take this piece of paper and we're going to fold it in lengthwise like EA. Try to get it as close to perfect as you can so that it goes right down the center. Then see, I've got that. Now I'm going to fold the front of the glider. I'm going to fold it in a 45-degree angle. And I'm going to do the same thing on the other side. So you come up looking like this. Now, we're going to take this edge and we're going to fold it so that it's right even with the center crease of that paper, where you, like that. And then we're going to fold the other crease just like this. Come out fairly close. And I'm not exactly perfect, but you don't have to be perfect to do this. When I made this one yesterday, I spent a lot of time trying to make this perfect. But anyway, now we can, they'll fly even if they're not perfect. So now we can crease this like this, and we have this. Now in this particular glider, we have some lines here that indicate where to fold to make the wing. So I'm going to fold that like that. Now keep in mind there are dozens of ways to make paper gliders. This is just the one way we're making this one. And there's also the same lines on the other side. So now I have a glider. But interesting thing about the parts of the glider, parts of an airplane, you have the fuselage, which is this part right here. This is the fuselage. Yeah, the cockpit where the pilot sits. You have the wings. Now this is actually a delta wing. Delta wing. There were lots of planes in the 60s, 70s that were delta wings. The F-106, for example, F-102. Now, at this point, you really have a glider that will fly. You really don't need to go much further to do this, but you can bend the little wingtips up here to give yourself some winglets. That's what they call these. And here we go. Now, I'm going to go back to the slides here a minute and show you some things about flying this glider. Because if you were to balance this glider on your finger, let's see if I can balance it. Notice that's the center of gravity wherever it balances. That's the center of gravity. Whoops, there you go. But now the center of lift, if that's the center of gravity right there, the center of lift is right there. So the wings are going to lift around that center of gravity. So it's going to go, if we fly it, it's going to go bang, nosedive. So this is what these in the back are for. And you can use some scissors, you can cut these ailerons, they call them. And what you're going to have to do is form these up just a little bit. As you can see there, so that they will push down on the wing a little bit so that it holds the wing level. And you have to experiment with these. Let's go ahead and go back to the share screen, and I'll show you, find the, where the heck did it go? Ah, here it is. Let's go to current slide. Okay, everybody see this okay, I hope. You'll see here that here's the center of gravity, and it's representing the center of pressure. That's where the lift of the wings. And here's another representation of that. So now what we're doing over here is we're creating a little pressure that pushes down on this to keep the wings level. And we'll go around that center of lift. We did this. This is a procedure that we went. This is a procedure that you can download from the product website, and it actually it shows you these drawings. Now let me stop share a minute here, and let's see how this flies. See if I can move the thing around here. Well, it flew pretty good. Let's fly this other one. So you can experiment. Now, the thing is, we're flying it probably at a speed of about 3 or 4 miles an hour. So now to answer the question, will that glider fly? Let me go back to share screen. Where is it? So I doubt very seriously that glider is going to fly on Mars. You'd have to fly very fast, almost the speed of sound here, but it'd be different up there. But now just a little bit about Civil Air Patrol. This is we're flying our glider here in down in Socorro. This is a cadet receiving an O-ride and being pulled by one of our Civil Air Patrol airplanes. And we're inside that glider looking out. It's a beautiful day for glider flying. A nice thing about glider flying, we don't have to have those waves to climb. We can use clouds. See how the bottoms of these clouds are? There's clouds are pulling up air underneath them, and we can get underneath one of those clouds once we release from the airplane there. And the air going up into that cloud will pull us up. We don't go into the cloud, but we can be pulled up by that air. One of the things about Civil Air Patrol, the cadet program, these are the different things that you can do to in the Civil Air Patrol. And then of course I put this one in here. These were some teachers that just got their airplane ride. We call our O-rides. There's a whole lot of other things that teachers can do. Let me go back and stop share. So, I hadn't checked chat. Let me see if there's any. Yes, the video is at parionproject.org. You have to kind of search for it. They've got several videos. You go into their, you might have to search around. I had to search a little bit. Hey, Alexandria, hey, great. Hopefully this year we'll be able to have encampments, and hope you'll be there. Any other questions? I might, since I got a little more time here, I might try to get that video. Maybe I could see if I could find out how to share it, because it should share okay. And I certainly look forward to next year when next year I'm hoping that the museum will be able to have this live again, and we can make the paper airplane there, and we can launch it on their paper airplane launcher. It launches it pretty quick.